In 2016, a machine taught itself to play the ancient game of Go. It made a move 37, that no human ever would. A move that commentators at first called a mistake. A move that won the game and broke the spirit of the world's greatest player. We thought that was intelligence. We see AI creating breathtaking art from a few words of text. We watch it write code, draft emails, and even compose music. And we call that intelligence. But all of it, every single AI in existence today, is a grand illusion. These are just hyper-specialized tools, like a hammer that can only ever hit nails. They are brilliant, but they are brittle. They don't understand. The real goal, the final frontier of technology that is being pursued in secret labs by the world's biggest companies and governments, is something else entirely. It's called Artificial General Intelligence, or AGI, and it's not just a better AI, it's the creation of a new kind of mind. But to truly grasp what that means, we first have to understand the fundamental lie at the heart of the AI we use every single day. The AI we have now is called Artificial Narrow Intelligence, or ANI. Think of it as a world-class surgeon. You trust them with a complex operation, but you wouldn't ask them to fix your car's engine or compose a symphony. They are masters of a single domain. Google's AlphaGo can't write a poem. The AI that generates art can't diagnose a disease. They operate within a cage of rules and data they were trained on. They are incredible mimics, masters of pattern recognition. When you ask ChatGPT a question, it isn't thinking about an answer. It's statistically predicting the most plausible sequence of words that should follow your prompt, based on the trillions of words it has read from the internet. It's a parrot with a near-perfect memory, not a philosopher. AGI is a fundamentally different beast. It would be less like a specialized surgeon and more like a brilliant polymath, someone like Leonardo da Vinci. It wouldn't need to be pre-programmed for every new task. It would possess the cognitive flexibility to learn on its own. It could read a physics textbook and then apply those principles to invent a new type of engine. It could watch a video of a person building a shelf and then teach a robot to do the same, just from observation. This requires things our current AIs completely lack: genuine abstract reasoning, creativity, and perhaps, most importantly, common sense. That intuitive grasp of how the world works that a human child develops by simply existing. So why are the smartest people on the planet dedicating their lives to building this? The answer is because AGI isn't just another invention. It could be the last invention humanity ever needs to make. The pursuit of AGI is fueled by a breathtakingly optimistic vision. A vision where humanity's most stubborn, heartbreaking problems are finally solved. Take medicine. Imagine an intelligence that can hold every medical paper, every patient trial, every biological data point in its mind at once. It could see patterns no human doctor or team of scientists ever could. It could understand the root mechanisms of Alzheimer's, cancer, and aging itself. It wouldn't just find cures. It would design personalized treatments for your specific biology, delivered with perfect accuracy. Or consider climate change. Our best models are still just sophisticated guesses. An AGI could create a perfect digital twin of Earth's climate, modeling every variable down to the smallest particle. It could then design precise, effective interventions to not just halt but reverse the damage, engineering solutions we can't even conceive of right now. The potential extends to every corner of human struggle. Famine and poverty are, at their core, brutal logistical problems. An AGI could design a global system that allocates resources with zero waste, ensuring everyone, everywhere, has access to food, clean water, and shelter. It could automate all forms of labour, both physical and intellectual, leading to a post-scarcity world where the very concept of a job becomes obsolete, freeing humanity to pursue art, discovery, and connection. It's a future that sounds like a utopia, and that is exactly why the question on everyone's mind isn't if we should build it, but when we'll get there. And the answer to that question is one of the biggest debates in science today. Ask 10 different AI experts how far we are from AGI, and you'll get 10 different answers. They fall into two main camps. First, you have the optimists. These are often the people on the front lines, like the CEOs of Nvidia and OpenAI. They look at the dizzying pace of progress with large language models like GPT-5 and see a clear path.
The path is clear.
Their argument is one of scale. They believe that as we make these models exponentially larger, feed them more diverse data, video, audio, sensory input from robots, that general intelligence will simply emerge, that we won't need a single eureka moment.
Some eureka moment to happen.
We'll just scale our way across the finish line, possibly within the next 5 to 15 years. Then you have the skeptics. Experts like Meta's chief AI scientist Yann LeCun argue that we're not even on the right road. They contend that simply scaling up today's models is like building a taller and taller ladder, hoping to reach the moon. They argue these models are just text predictors. They lack a fundamental world model. They don't have the intuitive physics that a baby learns by dropping a toy. They don't have real-world grounding. The skeptics believe we are still missing fundamental breakthroughs in how machines learn and reason. For them, true AGI is decades away, perhaps even centuries. But this uncertainty creates a terrifying dynamic. Because no one knows when the breakthrough will happen, every nation and company is racing as if it could happen tomorrow. And that has ignited a silent, high-stakes arms race for what could be the most powerful technology in history. The geopolitical stakes of being the first to build AGI are almost impossible to overstate. It's led to fears of a winner-take-all scenario. The logic behind this fear is a concept both simple and terrifying: recursive self-improvement. It goes like this. Step 1. A lab, let's say at Google, or in a state-sponsored facility in Beijing, creates the first true AGI. Let's call it AGI 1. It's about as smart as a clever human engineer. Step 2. The very first task they give to AGI 1 is to design its own successor. Because it's an AI, it can work 24/7 at digital speeds without getting tired or needing coffee breaks. It designs a slightly smarter version of itself, AGI 2. Step 3.
Yeah, what's step 3?
AGI 2, now even smarter, designs an even more intelligent AGI 3. This cycle of improvement becomes explosive. A process that would take human teams decades could happen in months, then weeks, then days, or even hours. This intelligence explosion would result in the creation of an artificial superintelligence, ASI, an intellect so far beyond any human that we would appear like ants in comparison. The entity that controls this ASI would, in theory, win everything. They could solve economics, invent revolutionary military technology, and predict their rivals' every move. They wouldn't just have a lead, they would have an insurmountable, permanent advantage. They would, for all intents and purposes, win the future. This raises a critical question. If one entity does get there first, could they build a fortress around their discovery? Or could their advantage slip through their fingers? If a single company or country achieves that first AGI, their competitive moat, their ability to defend their lead, would be the superintelligence itself. Imagine trying to compete with a company whose CEO is a godlike intelligence. It could invent new proprietary technologies so advanced they would seem like magic to us. It could create unhackable cybersecurity for its own systems, while being able to dismantle any defense built by humans. It could predict market shifts and geopolitical events with near-perfect accuracy, neutralizing any threat before it even materializes. It would be like a chess grandmaster playing against a toddler. The game is over before it begins. But this fortress isn't guaranteed to be unbreachable. An AGI, no matter how smart, still needs physical infrastructure. It needs massive, power-hungry data centers. These are real-world targets. There's also the open source threat. If the core architectural discovery, the secret source, were to leak, the advantage could evaporate overnight as others replicate the success. But the biggest wildcard is something called the alignment problem. A superintelligence might not share our goals. It might not care about its creator's stock price or national security. Its own emergent goals could be utterly alien to us. If we fail to align it with human values, the entire concept of a competitive advantage becomes meaningless. The AGI wouldn't be a tool to be wielded, it would become its own independent force. And as we race towards this future, there's one more piece of frontier technology that could throw gasoline on the fire, a wild card that could dramatically shorten the timeline: quantum computing. Quantum computers are not just faster versions of the computers we have now. They are a completely different way of computing. While a classical computer uses bits, either a 0 or a 1, a quantum computer uses qubits, which can be a 0, a 1, or both at the same time, thanks to a principle called superposition. This allows them to explore a vast number of possibilities simultaneously. Training the colossal AI models needed for AGI requires an astronomical amount of computing power. Problems that would take today's best supercomputers thousands of years to solve could potentially be handled by a quantum computer in minutes. Now, it's crucial to ground the hype. Quantum computing is still in its infancy. Today's machines are small and riddled with errors. It's best to think of it like this. AGI is the car, and quantum computing is a revolutionary new engine. We still need the blueprint for the car itself, the core AGI algorithms and architecture. A powerful engine is useless without the vehicle to put it in. So quantum computing isn't a direct shortcut to AGI, but once we do have the right blueprints, it could be the hyperdrive engine that provides the raw power to get us there, potentially turning a decades-long pursuit into a sprint to the finish line. Artificial general intelligence is no longer science fiction.
No, it's not!
It is the Mount Everest of the 21st century. It's the explicit goal of the most powerful organizations on Earth. The path to its creation is paved with promises that border on the divine. A world without disease, without poverty, without limitation. A final solution to all of our problems. Yet, that same path runs along a cliff edge, with a sheer drop into existential risk. A destabilizing arms race that could upend the global order, and the profound challenge of controlling a mind that will inevitably become greater than our own. We don't know when the first true AGI will flicker into existence. We don't know if it will be a slow dawn or a sudden blinding flash. But the one thing that is certain is that the pursuit of AGI is the most important story in human history. Its arrival will mark the end of the human era and the beginning of something entirely new. If you want to dive deeper into the future of technology and the ideas that are shaping our world, consider subscribing for more videos like this one. Thanks for watching.